Hello everyone, and welcome to lesson number 8 of my deep learning course. In this lesson, we will start to tackle our first deep learning task, all from scratch. So, without further ado, let's get started. Whether you want to implement AI into your business or you just need consultancy from a machine learning expert, I'm the right person for you. From acquiring data till deployment, my multiple years experience will provide you full support which will help you to boost your business. To find out more, check the link in the video description. Welcome back everyone. So this is going to be a mini series where we will learn how to solve a binary classification task from scratch, including dataset creation. If this is the first video that you're checking from my series, I recommend you to go to lesson number 1, where I explain you how to set up the Jetson Nano for deep learning and how to program it for the web interface like we are doing right now. As always, the Jupyter notebook of this lesson is going to be linked down in the video description. So this mini-series is going to be divided into 3 parts: dataset creation, network creation, training, and improvement. And in this Jupyter notebook, we will start from creating the dataset. If you have any question, feel free to ask in the comment section down below. So as always, here is going to be the video of this lesson. In this case, it's lesson 7. Of course, as soon as I upload on YouTube, it's going to be lesson 8. Don't forget to like, subscribe, and activate the notification bell. So before we start, let's make sure that we run the Jupyter notebook using the TensorFlow 2 virtual environment. So we execute this code. If you guys get any error, as always, you can go up here and change the kernel to TF2. Okay, so talking about the task to solve. The task to solve is simple. Given a set of coordinates x and y, we have to classify if a point corresponds to the class 0 or the class 1, based on its coordinates. So let's create a dataset for this task. We will use a nice function from the package scikit-learn. So in one line, we can see that with makeBlobs function, we can create a dataset with 5,000 data points, 2 features, then some parameters for the standard deviation, number of centers, and so on. So we execute this code. Now remember, the first step in any machine learning task always start from visualizing the data. So let's start from that by executing this code. And as you can see, here is the graph. So as you can see, the clusters are overlapping a little bit, especially here. You can see where the clusters are very close to each other due to the standard deviation. And this task is not that obvious. It's not so complicated, but it is also not that obvious. As you can see here, there is a lot of overlapping. So just based on the XY coordinates of these dots, is pretty difficult to say whether it's belonging to one class or another. So if you want to make sure that the neural network is not memorizing the data that it's seeing, but is learning the task, then we have to split the data into 2 branches, training and testing. If you're wondering why we don't split data into training, validation, and testing, the answer is because the task is very simple and we don't need a constant monitor of the neural network's performance, so it's not mandatory. Plus, remember that this data is created by constructing clusters. So training and test and eventually even validation, they all come from the same distribution, so there is not much of a difference. Later in the course, I will explain how to properly select the data. So this is going to be a little bit different, but for the purpose of this video, we will see just with training and test. So to split the data, we can use a simple function from scikit-learn, train test split, where we specify the data and the size of the test data. So we execute this code. Now we need to visualize this operation so that we have an understanding of the training and the test data. So we execute this code. Okay, so now we can see on the left side the training data and on the right side the test data. As you can see, the data is very similar, so it's coming, of course, from the same distribution. There is still the same kind of overlapping. Some points, of course, are different. For example, here we have a couple of points belonging to the orange class instead of the blue one. Here there's not. But overall, they look pretty similar. Now let's talk about data analysis. Data analysis is a critical step in machine learning, and unfortunately, oftentimes unexperienced machine learning developers use the data without even taking a look at it. So just feeding it directly into the algorithm and hoping for the best. If you want to improve the performance of your model, you always have to start from the data, and then you need to improve the model. This task is very simple, but we can notice two things. The data is in the range +10 to -14 on the y-axis, and we can see it here, and -10 to +14 on the x-axis. You can see it here. And if you saw my previous videos, you know that this impacts our choice on which activation function to use. Another option would be to normalize the data within a smaller range so that we can use different activation functions. One more thing that we need to pay attention to is to check whether the data is balanced, both in the training set and in the test set. Imagine the scenario in which we are training only on one class and only a few examples from the other class. The learning will be very, very imbalanced. So you will have a lot of problems. Same also in the test set. So maybe the training set is balanced, and then when we go into the test set, there are only examples belonging to one class. That's surely going to bring problems, of course. So we will evaluate only if the model is able to predict one class and not the other. So first, let's check whether the data is balanced by executing this code. Perfect. We can see that the data is perfectly balanced between the two classes in both data sets. We can see for the training data that here we are pretty good. So 2000 examples for one class and 2000 for the other. Same for the test data, 500 and 500. Roughly. Doesn't have to be, of course, exactly precise. Now let's create copies of the same data sets, but this time we normalize the data using min-max scalar and standard scalar from scikit-learn. Now remember that the test data cannot be seen at all during the pre-processing step. This is where usually people make mistakes. So first we split the data into training and testing. Then we consider only the training data for our pre-processing function. And then we apply the same pre-process technique on the test data. We don't do the pre-processing and then the splitting. This is a very important topic. So we can execute this code. And now we can visualize the results by executing this code. So now in this first graph, we can see the training data after the min-max scalar. So we have the features now, every point within a range of 0 and 1 for y and x coordinates. And then you can already notice for the test data, we have some points outside this range of 1 and also here on the x axis. And this is expected. That's exactly why we need to process the training data and then to apply the same pre-process on the test data and not calculate and pre-process everything together and then split. Because when comes some other data point in the future, we are not able to recalculate the pre-processing and retrain everything, of course. So we want to base our pre-processing techniques only on the training data and then just applying on the test data. So now here on the left side, you can see the training data after the standard scalar, and on the right side, the test data after the standard scalar. And we can notice another thing actually between these two normalization technique. So if we see the min-max scalar, the data is pretty balanced in between. So at 0.5 on the median here is pretty much balanced. When we go in this other normalization technique, on the point 0 is not balanced as well. So, and that makes sense. If you remember in the raw data, the range was from +10 to -14, was not between plus and -12. So here the distribution is respected, so where the points are located, with min-max scalar instead not. And this is also something important because will affect also the training performance. Anyway, those are just two normalization techniques, and I encourage you to try out other techniques. So I left a handy link here so that you can just click and go to scikit-learn and check what other kind of normalization technique you can apply to the data. If you try something new, let me know in a comment down below, and if you find some problem, feel free to ask. Okay, so now we are reaching the end of this lesson, in which we have to save the data for the upcoming lessons. Remember, it's a good practice to save the data before training after the pre-processing. This ensures that the data will not be modified between different runs. And this is very important. This can be also a question that people might ask you during an interview. So usually what we do from the data, we analyze the data, we do some pre-processing, we try different techniques, and then we save this data. Why we do this and we don't do this on the fly? Because we want to make sure that when we train, since we need to train different times and check and make some consideration and adjust some parameters of the network, we want to be sure that the network, the difference are coming from the adjustments in the network and not from the data. So if you are not relying always on the same data, then you don't know whether the performance is increasing or decreasing based on the adjustments that you're doing or based on the different data that you're feeding to the network. So let's execute this code. This is pretty straightforward. This is using the h5py module from Python, and we create only one file and we save all the data set that we create, included the raw one, plus of course the data with the min-max scalar and the standard scalar. Now, just to make sure that everything works as expected, let's try to read this data, and we print the shape to make sure that everything works correctly. So we execute this code, and as you can see, we can read the data and everything works as expected. So that's it for this video. If you guys like my content, you can support me on Patreon, where you can speak directly with me, and also I can give you advice on how to get started into this career. Another way to support this channel is to use my affiliate link that I give you in the video description for your purchases at no cost for you. Finally, another way to support me is to subscribe and share this video on social media. So I thank you for now, and I hope to see you in my next video.